This is part 4 of the Chapter 13 lecture. There's 2 topics in this lecture. Hydrates, we'll get the definition and how to calculate the molar mass and look at how they're named. And then the second thing is talking about water. So a hydrate is a solid. And it has, what makes it interesting is that it has water as a part of its crystal structure. So the water is not dissolving the solid. It looks like a solid, so it looks like table salt. Although some of them, like if they have copper in them, they'll be a pretty blue color. But it just looks like a solid. You can imagine table salt. And the unique part of it is that there's water that's trapped inside the crystals of that solid. If you were to place some in a crucible and then use a Bunsen burner to heat it up, you could actually evaporate the water out of the crystal structure, and then it's called something, it's called anhydrous. So the water can be removed with heat. But it's not dissolving it. It's a solid, so get that into your mind. It makes the formula written a little bit differently. So here's an example. So it's a regular ionic compound, like this is just calcium chloride. But when it's a hydrate, it has a dot, and then it will have a coefficient here, and then the water. And this coefficient can vary between the different substances, so they don't all have the number 2. It depends on what the hydrate is. Now, how you name them is you name the ionic compound, and then to say that it is a hydrate, you use the prefixes that we learned in Chapter 6 to tell how many waters there are, and followed by the name hydrate. So looking at this one here, it would be calcium chloride. Remember, ionic compounds are simply named by naming the 2 ions. So there's calcium chloride. There's 2 waters, so then it's dihydrate. Let me erase that so we can look at it again together. So it's calcium chloride, because there's 2, and then hydrate tells you the water. So the one below it, this is iron 3 chloride. Remember, iron needs a Roman numeral, so that's just the ionic compound. This has 6 waters, so they use the prefix hexa. So it's calcium chloride dihydrate or iron 3 chloride hexahydrate. So really the hydrates are named similarly to the ionic compounds, but then you use prefixes to tell how many waters there are, and then the word hydrate. Now, the main reason I want you to feel familiar with this is because in Chapter 14 in the past, there's been a homework problem that uses a hydrate when we're calculating concentration. And so if you have a hydrate, the water is a part of its crystal. So if you need to calculate the molar mass of a hydrate, you have to include those waters. So let's do an example. And I'm just writing here, include the water when calculating the molar mass of a hydrate. Oops. If you have a periodic table, look at it now. If you don't have one nearby, you can pause the video and go get one just so you can remind yourself where I'm getting these molar masses. I'm going to pull one up on my laptop so I can look at my molar masses. Okay, periodic tables. So maybe you've gotten yours now. Let me get one. So many choices, and I just need to know the molar masses. Okay, let's see if I got one. Oh, it's tiny. A second. Okay, there we go. Sorry about that, but I don't remember calcium. Okay, so we would have, if I wanted to calculate the molar mass, I have what? 1 calcium. And if I look on, that's what it took me so long, 40.08 on the periodic table. Okay, and then the chlorine, we have 2 of them. They're 35.45. So what is that, 70.1? 70.9. 70.9. And then I have 2 waters, and you could break it up 2 different ways. Water is like 18.02, so you could do it that way, or you could break it up into its hydrogens and oxygens. It doesn't matter as long as you're including everything. So if I wanted to break it up into hydrogens and oxygens, let's see, it's 2 times 2, so there's 4 hydrogens. And then 2 times 1, the oxygens, there's 2. And so then you're going to take all of these and add them up, and that will equal, let's add it, 40.08, 70.9, 4 plus 32. And it's 147.02. That's the grams per mole. So the big thing here is it's not something new to us to calculate molar mass. You're getting very good at that. What's new to us is when you have a hydrate, that water is a part of the structure. So if you have a problem and you need the molar mass of a hydrate, you need to include the water as a part of the molar mass. All right, so while we're talking about water, I have one more slide in this section. And just a few things about water, and I will put a star by the things I want you to know in your mind. So water is a unique liquid. So if you look at the first part here, and I'll put a star by it, so not this yet. I'll tell you what I want you to memorize. So water covers 75% of the Earth's surface, 97% of the water resides in oceans. So that's just a little bit about water. But it also is a reason why there are sometimes water shortages if 97% of the water is salt water. Water consists of 70% of the human body by mass. So we also have a lot of water in our bodies. So those are interesting things. You don't have to memorize those for this class. So physical properties of water. I do think we need to know this about water for our expectations, and hopefully you might already know this, that water is colorless, odorless, tasteless. It's a liquid. And this is a very unique property of water, and that is that its liquid is more dense than its solid, and that's the reason ice floats, which is unique. Usually a substance's solid is more dense, so the solid will sink, but not for water. And then because of its hydrogen bonding, water has a very high boiling point, high heat of fusion and vaporization. So it likes to stay together is kind of how I think about it, because it has really strong intermolecular forces. So the three things that I put the asterisks by are the three things that you should try to learn about water and just have as a part of your basic knowledge moving forward.